Let us look at proposition number 8 of book 11 of Euclid's Elements. The proposition says, if two straight lines are parallel and one of them is at right angles to any plane, then the remaining one is also at right angles to the same plane. Let's see how we can prove this. We are given that AB is perpendicular to the plane of reference. Now, what we'll do is we will join B and D. Then AB, BD, and CD, they all lie in a single plane, in the same plane. If I rotate it, it will become clearer. So let's first draw that plane. So this is the plane in which AB, BD, and CD are. Now we draw a line BE perpendicular to BD in the plane of reference and equal to AB. So let's do that. Let's first draw a line perpendicular to BD. Let's draw a circle with the center at D and radius as AB. And take one of the intersections and let's hide off this circle and the line. Now let's join BE, AE, and AD. Remember, AB is perpendicular to the plane of reference. That means AB is perpendicular to all the lines in the plane of reference and meeting it, which means BD and DE are meeting AB and they lie in the plane of reference. So that means angle ABD is right angle and ABE is right angle. BD traverses through two parallel lines. That means angle ABD plus BDC is equal to two right angles, that is 180 degree. And since one of them is 90 degree, the other one is also going to be a right angle. So CD is perpendicular to BD. Remember, we have to show that it is perpendicular to the plane of reference. Here we have just shown that CD is perpendicular to the line BD. Now let's look at the triangle ABD and BDE. ABD and BDE. These two triangles are congruent. How? Because BD is the common side. By construction, AB is equal to DE and angle ABD is equal to angle BDE. I have not shown BDE, but that is right angle by construction. So these two triangles are congruent. Now, if they're congruent, that means AD is equal to B. Now, let's look at the other two triangles. Triangle ABE and ADE. Again, these two triangles are congruent. How? AE is common. AB is equal to DE by construction. And we have just proved that AD is equal to BE. And since these two triangles are congruent, it means that angle ABE is equal to the corresponding angle ADE, that is this angle. And since this is 90 degree, that means this is also a right angle. So which means DE is perpendicular to AD. And DE, remember, by construction is perpendicular to BD. So therefore, DE is perpendicular to the plane which passes through AD and BD. So which means DE is perpendicular to all the lines which meet it and lie in the plane through AD and BD. And we know that CD is also in the same plane which passes through AD and BD. So DE is perpendicular to CD as well. Or we can say CD is perpendicular to DE and CD is perpendicular to BD. Oh, because remember this CD is perpendicular to BD was with respect to lines. What we have to show is CD is perpendicular to the plane of reference. So CD is perpendicular to DE and BD. So therefore, CD is perpendicular to the plane passing through DE and BD. But what is the plane which is passing through BD and DE? That is our plane of reference. So we have shown that CD is perpendicular to the plane of reference if AB is perpendicular to the plane of reference. So that is proposition number 8 of book 11 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.